Okay, today is day 2 of grade repair, and we are starting off with lesson 1.3. So today we are starting day 2, and we're doing conversions and formulas today. So for 1.3, it was all about converting something to a different measurement. Remember that the word convert means to change. So it's still the same measurement, but I'm just converting it to a different unit. So for like the first one, I'm going from feet to inches. Whatever they give you at the beginning, so they give me this 4 feet, that's what I'm going to start off with. So I'm going to make a fraction with that 4 feet, okay? So 4 feet. I'm going to place it over 1. I'm multiplying. Depending on how many like units of conversion they give you in the parentheses, that's how many more fractions we're going to have. So we have our initial fraction and we're going to have one more. If feet is on top, feet has to go on the bottom, right? Because we want those to cancel. Always write the words first and then go back and plug in the numbers. So the number in front of the word feet is the number 1. That means the 12 inches will go on top. All right, at this point, I'm going to cross off the stuff that's the same, so my units, so like feet goes with feet. Then at this point, I multiply all the top and I multiply all the bottom. So 4 times 12 is 48. Don't forget the inches. And then on the bottom, I get 1 times 1, which is 1. You can simplify that. So 48 divided by 1, you get 48 inches. Okay, don't forget to show all your work, and then don't forget the units as well, right? That's crucial. All right, letter B. You're given 5 hours to start, and you want to go to seconds. So you see how I have 2 units of conversion here, like I have 2 things? I'm going to have 2 more fractions on top of my original fraction. So I have 5 hours, okay, over 1. If hours is on top, hours has to go on the bottom. Okay, then I'm going to look for the unit that has hours, and it's this one right here. The number in front of hour is 1. So that means on the top, I'm going to have 60 minutes. Okay, I already used this one, so I'm going to cross it off. But I have to keep going because I want seconds. If minutes is on top, minutes has to go on the bottom. The number in front of minutes, I already used the first one, so I want to use the second one, is the 1. So the 1 goes here. That goes with 60 seconds. Then I can see what I have in common. So hours with hour, minutes with minutes. I'm left with seconds. That's what I want. Then I multiply all of the top and all of the bottom. All right, so on the top, I have 5 times 60, which is 18,000. And on the bottom, I get 1. So I get 18,000. And then don't forget your units, so seconds, over 1. And then I can simplify that and make it a little bit nicer. So I have 18,000. And then seconds. Okay, that's my answer. All right, letter C. So Joe travels at a constant speed of 80 miles per hour for 10 hours. So let's do that part first. So I have 80 miles, okay, per hour. So for every 1 hour. This is a little bit different than the ones we did up here, okay? And I want to know how many miles he'll travel in 10 hours. Okay, if hour is on the bottom, hour has to go on top. And I'm talking about 10 hours. So I have 10 hours. I'm going to put my 1 here. Hour cancels with hours. Those are the same. Then I multiply all the top and all the bottom. So 80 times 10 is 800. Okay, miles over 1. 1 times 1. And then if I clean this up, this is 800 miles. Okay, then I want to know how many kilometers he's going to travel in 10 hours. So now that I have my miles and I've already converted them, I'm going to use that to help me find the second part. So I have 800 miles over 1. And then here, if miles is on top, miles goes on the bottom. So I'm going to write mile. I'm going to use the conversion that they give me. The number in front of mile is 1, so the 1 will go on the bottom. That means the 1.6 will go on top. Miles cancels with miles. I multiply all the top. I multiply all the bottom. So 800 times 1.6, I get 1,280. So 1,280 kilometers. On the bottom, I get 1. To clean this up, I get 1,280 kilometers. Okay, now we have these trites on the bottom. So I will set them up for you, and then hopefully you can calculate the answer. So they give me the 600 centimeters first. So I have 600 centimeters over 1. If centimeters is on top, centimeters goes on the bottom. The number in front of the word centimeters is 100, so the 100 will go on the bottom. That means 1 meter will go on top. Centimeters cancels with centimeters. I multiply all the top and all the bottom. So on the top, 600 times 1 is 600. Don't forget your units. And on the bottom, I have 1 times 100, which is 100. Remember, you can't leave your answer like that, so I'm going to divide those. So 600 divided by 100, I get 6. So my answer at the end is 6 meters. This one's different than the ones we've been doing because you have to divide at the end and your answer does change. Okay, let's try letter B. So we're going to start off with the 10,800 seconds. Okay, over 1. If seconds is on top, seconds has to go on the bottom. Look for where you see seconds. Seconds is right here. The number in front of that is the 60. So the 60 goes here, and that goes with 1 minute. Okay, but I'm not done. Once I use a conversion, I can cross it off. Okay, if minutes is on top, minutes has to go on the bottom. The number in front of the word minutes is 60. That means 1 hour will go on top. Seconds cancels with seconds. Minute cancels with minute. My equal sign. Then I have to multiply all of the top and all of the bottom. So on the top, 10,800 times 1 times 1, that'll stay the same. And then don't forget your units. So we have hour. And then on the bottom, I have 1 times 60 times 60. So that's 3,600. My last step is to divide those to see how many hours it takes. So 10,800 divided by 3,600, I get 3. So I'm left with 3 hours. Again, that one was a little bit different than the other ones. These two are similar in that you have to divide at the end to get your final answer. All right, we are now going to move on to function machines. All right, when we're talking about function machines, just be very careful about what you're plugging in and what you get out, so your input and your output. So for the first one, the worker put a 3 in the machine, and they got an answer of 8. What did the function machine do? So the worker put in this x equals 3, and they put it into this machine, and they got out this answer of 8. Okay, so the worker puts x equals 3 into the function and got an output of 8 out. Okay, so here's what they did. They have x equals 3, and they have this machine. Okay, so I have this x squared minus 1. Anywhere that I see the letter x, I'm replacing with the number 3. Be careful how you replace it and you plug it in because parentheses are important. So I'm going to take the x out and I'm going to plug in the number 3. So I'm putting it in parentheses. The little 2 is still there, the exponent, minus 1. And then I want to see if that truly gives me 8. So 3 squared minus 1, I get 8. So this does equal 8. So we had something that we put in, and then we got something that we got out. So this is my input, and this is my output. Okay, let's try a different one. So here, be careful when you're reading these. It's not fx. The way we read this is f of x, so it's written right here. The letter may change, so if you see G, it's G of x. If you see H, it's H of x, so just be careful about how you're reading it. They're telling me to find the output for this function when the input is x equals 14. They're telling me to plug this in. So just so you know, this is the same as this. So you'll see both notations. Just know that if it's written either way, they're the same thing. All right, here's my function. I see 2 x's. So in those 2 spots, I'm going to plug in 14. Okay, so I have f of 14 is 3 times 14 minus 1. F of 14. I like to tell my students this is all calculator. And we're only plugging in this side, not this f of 14. So this is 3 times 14 minus 1. I get 41. All of this is your answer. Okay, so please, please, please be careful how you write it. Don't just go like this. Just rewrite the whole thing. So don't be lazy, rewrite the whole thing. Okay, let's try these. Same function, so same function, the one from the box, this one, and we're given 2 numbers to plug in. So in those 2 spots for x, I'm going to plug in x is negative 10. So I have f of negative 10 equals 3 times negative 10 minus 1. The left side with the letter f stays the same. This goes in your calculator. 3 times negative 10 minus 1. I got negative 31. For letter B, I want you to try it on your own. So if you want to pause right here, you can and try it. And then I'll show you what the answer is. Okay, so hopefully you paused it and you did try it. You should have gotten the answer like this, and your answer should look like this. So if you just wrote negative 7, you are going to get marked wrong on the test because you want to make sure that you write the full thing, right? So like this is my full answer. All right, let's try example 3. Example 3 is tricky. Every time we've done this so far, they've given us the input. Okay? Example 3 says if the output is 24, that means if the answer is 24, that means f of x equals 24. I'm just going to rewrite my function here so that I can show you what it's telling us. This is saying f of x is 24. So I'm going to look for the letters f of x, so f and x, and I see them right here. What I'm doing is I'm plugging in this 24 in the spot for both of those letters. This is my answer. So I'm taking out those letters and I'm plugging in 24. Everything else will stay the same. I'm going backwards. I'm trying to figure out what my input is. And then from here, I just solve for x. So I add 1. These cancel. I get 25 equals 3x. Divide by 3. And we like to leave our answers as fractions, but let's still plug it in. So 25 divided by 3. Remember, we can do math, enter, enter. So we're going to leave it as 25 over 3. So x equals 25 over 3. That's my input. You see how my answer looks different than up here? It's two different questions. The top 3 gave me my input, the bottom one gave me my output. All right, let's turn the page and let's do some more problems. All right, so for these 4, they're giving us either the input or the output. All right, so for letter A, I have x equals 8. So anywhere that I see the letter x, I'm going to replace it with the number 8. So in those 2 spots, I'm going to replace it with 8. So f of 8 equals absolute value of 8. Remember that the absolute value makes anything positive. So I have f of 8 equals, this is now just 8. Drop the absolute value and it's just 8. All right, letter B. They're telling us that I'm plugging in 2. So anywhere that I see the letter 2, so in those 2 spots, or see the letter x, sorry, I'm plugging in the number 2. So I have f of 2 equals 3 to the 2nd power plus 1. So I have f of 2 equals, and then if I plug that into my calculator, I have 3 to the 2nd power. Make sure you don't stay in the air, you get on the ground, so you got to press the right arrow key. You can press it as many times as you want, plus 1. I get 10. So this equals 10. Okay, perfect. Let's try letter C. So anywhere I see the letter K, I'm going to plug in -6 instead, and I see it in 2 spots. So I have f of -6 equals -6 over 2 plus 1. So f of -6 equals, remember to make a fraction, you do alpha y equals, enter. So -6 over 2, and then plus 1. I get -2. All right, good so far. The last one's a little bit different. The last one, letter D, they're giving you the output, and you have to tell me the input. So this is like that last one we did on the first page, or on the previous page. So this is the answer. The answer is going here. So this -4 is taking the spot of those 2 letters. So take out those letters and let's put a -4. Everything else will stay the same. Okay, now I just solve for x. The opposite of +6 is -6. -4 minus 6 is -10. Bring down that -2x, and then divide by -2. -10 divided by -2 is +5. That is it for function machines. The last one that we're doing today is domain and range. So we are going to do day 1 and day 2 in one, so it's a combined thing. Remember, domain is your input, it's your x values, so you want to look at left to right. And range is your output, it's your y values, so you want to look up, down. All right, I'm going to look at letter A. I think it's helpful when you're given a bunch of dots to make a table. So to make an X, Y table. You don't have to do this, but I think it is very helpful. I always start with the one that's on the most left. So this point right here, that's at negative 3, 2. And then I work my way to the right. So I already used this point. Okay, I'm going to do this one at the bottom. So this is negative 2, positive 1. This point up here is negative 2, positive 3. This point down here is negative 1, 0. Put an X. This one over here is negative 1, 4. And then I have my last two dots. This dot at the bottom is 2, negative 3. And this one up here is 2, 7. All right, my domain is my x's. My x's are these numbers. And we want to make sure we put them in order from smallest or from least to greatest, so to the most positive. We also don't repeat them. So what do I mean by that? My most negative or my smallest number here is negative 3. Okay, then I go in order. Then I have negative 2. But you see how it pops up twice? I only write it once. Okay, once I use them, I like to cross them out. Then I have negative 1, cross it out, and then I have 2. The last thing you have to add around this list are called braces. So they kind of look like brackets, but they're just like curly braces. So you just want to make sure you add your braces. We are going to do the same thing for range. We want to put them in order from least to greatest. And this time we're talking about the y's. So this is my y's. My smallest number here is negative 3. So that goes first. Then I have 0. Then I have the number 1. Then I have the number 2. Then 3. Then 4. The last thing I'm going to do is add my braces. Do we think this is a function? Remember, it's a function if your x's do not repeat. But you see how on my x side I have multiple x's repeat? Because of that, this is not a function. Okay, let's talk about letter B. Letter B is a line, and there are supposed to be arrows at the end of this, so just go ahead and add your arrows. Your domain is your x's, so from left to right. This goes to the left forever. This goes to the right forever. So your domain is all real numbers. For your range, it's your y's. This goes up forever. This goes down forever. So this one is also all real numbers. Is this a function? You can check by doing the vertical line test. If there are no points on top of each other, that is good. So this is a function. This is yes. All right, let's turn to the last page. All right, you're missing arrows on both of these, so let's add your arrows. All right, your domain is your x's. This goes to the left forever. This goes to the right forever. So your domain is all real numbers. Your range is your y's. Here you have to be super careful. Here's where you want to identify your lowest or your highest point. Because my graph is going up, I have a lowest point. My lowest point is right here. The coordinates that make up that point are negative 1, negative 3. Because I'm talking about the range, I'm only focused on the y's. This is my x, this is my y. So I'm only focused on the negative 3. So that's part of my answer. Okay, range involves y's, so I'm going to include a y. And because my parabola, my graph is pointing up, this is greater than or equal to. So just keep in mind, if it's pointing up like this, it's greater than or equal to. If it's pointing down like this is less than or equal to. So you could use this as a little cheat sheet. Is this a function? If I put my pen or pencil, do I have any points on top of each other? I do not, which is good. This is a function. All right, let's talk about letter D. Domain is my x's. This goes to the left forever. This goes to the right forever. So this is all real numbers. You can see the highest point here. The coordinates there are 2, -4. This is my x and my y. My range is the y's. So the -4, oh no, this is +4, sorry. +4. The 4, because that's my y, is part of my answer. So I'm going to write 4 here. Okay? Because range is the y's, I'm going to put the letter y. And because my graph is pointing downwards, it's less than or equal to. If I take my pen or pencil, there are no points on top of each other. So this is a function. So yes. All right, let's talk about function notation. Function notation means f of x. But always look at your problem and make sure that they don't use different letters because sometimes problems do. All right, when we're talking about function notation, we're always referring to this equation right here. But instead of the y, I'm replacing it with f of x. These two, the m and the b, represent different things. M is my slope, and b is my start. Right? You could also call it your y-intercept. You could also call this your change. So I have a gym membership that costs $55 for a sign-up fee and $30 per month. You want to think about between those two numbers, which one is changing depending on how long you're at the gym. The one that's changing is the 30. So that's my M. The 55 is my start because when you sign up, you pay $55. So that's my B. I plug those numbers into their correct spot. So this ends up being 30x plus 55. Okay? Explain the meaning of f of 10 equals 355 in context of the problem. So I'm talking about a gym membership, and I'm talking about the cost per month. This is my in, this is my out. This is my x, this is my y. My x is the months, okay? The 355 is the cost. So I can say something like after 10 months, the total cost for the gym membership is $355. So make sure you include your units and make sure you're very specific about what each number represents, right? The 10 is months and the 355 is dollars. Okay, perfect. Last problem for today. So you have a computer repairman that charges $40 plus $25 per hour. Write a rule in function notation and create a table to represent the money that the repairman charges for 1, 2, 5, and 10 hours. Let x represent the hours worked and f of x represent the total cost of the repair. Is this a function? Okay, these are the numbers that I'm plugging in. So I have 1, 2, 5, and 10. I have to write an equation. They tell me what letters to use, so I'm going to use those variables, those letters. Okay, so my equation is going to be f of x equals, remember, and I want to think about this right here. Of the two numbers, which one changes depending on how much he works? Well, that's the 25. So that ends up being my slope. So I have 25x. That means the 40 is my start. All right, in your calculator or on your phone, we're going to plug this in. So you're going to go to this top option in the y equals, and you're going to press it. If you have anything there, you need to clear it. We are going to type in 25x plus 40. So 25. The X is this button right here. So once I press it, an X will pop up, and then plus 40. In order to get the numbers in your table, you're going to press second and then graph. Second and graph, and then it gives you my table values. I am going to find these numbers on the left side and then write the correct Y number that goes with it. So for the number 1, I have 65. For the number 2, I have 90. For the number 5, I just got to scroll, 165. And for the number 10, I have 290. So that's a faster way that I could find my table values. The last thing I have to determine if this is a function. Okay, look at your X values. Do any of these numbers repeat? No, they don't. That's good. So because none of your X values repeat, we are going to say yes. The relation is a function because no X values repeat. And that's for every type of problem like this. So if the X's do not repeat, that is good. We like that. That means it is a function. All right, so that's it for today, and then we'll pick back up tomorrow.